I'm going to show you how to measure UV lamps. With the Viso LabSensor system and combined with our new UVC sensor, the LabSensor Model 2, we are able to measure UV lamps much simpler than ever before, and at the same time get the complete distributed light field coming from your UV lamp. I have mounted a prototype of a UVC lamp right here. This is a 254 nanometer lamp, and it's mounted on our LabSensor goniometer, so basically it will turn the lamp in all directions. We're going to get the complete radiated field from the lamp, and it's going to be used by it's going to be measured by the sensor right here next to me. So I think we are pretty much ready. So what I will do now, I will turn on the lamp, and remember, when you measure UV, be careful. It is pretty powerful light, so you need to wear glasses or use a curtain to cut off. So now I'm here with my computer and the light inspector software connected to the machine, and I'm ready to do my measurement. And I basically just click on the play button. I select to measure 2 planes and click OK. And now the machine will automatically measure the power consumed by the lamp. And starting the measurement, also the integration time is fully automatically set. It's actually measuring the flicker that might come from the lamp and sets the integration time to fit with that flicker period, making the complete measurement setup process fully automatically and accurate. And it's gonna start making the warm-up curve for the measurement. But let's skip this part because we want to see the measurement results quickly. So now the machine is going to the start position, and it's going to turn the lamp into the first plane that will be measured. And as you can see here, we are measuring complete spectrum from 200 to 850 nanometers. So it means we are measuring both UV and visual in one go. And the amazing part about the LabSensor is that we're actually measuring continuously. We don't have to start and stop. We are measuring UV and all photometrics at continuous movement, and therefore we can do the measurement extremely fast. And here we're doing a 2-plane measurement in about, probably less than a minute. So now the measurement is finished, and what I will normally do right when I'm finished, I'll just clean it up a little bit. Normally the lamp is always, it's difficult to get it precisely mounted within, half a degree correction, so I'll correct these small errors. So I'll correct the beam angle a little bit. I'll correct any intensity variation that's been during the measurement. And we can see that this lamp is giving, visually, it's giving 235 lumens. But of course, we're not interested in the lumen part. We are interested in getting our UV data. And in UV, we want to get watts. We want to work with power. So I'm basically just going to go in here to edit photometric and shift into power. And we're not interested in the power that is radiated in the visual area. We are interested in the power that is radiated within the 254 nanometers. So I'm basically just going to go in and type in, limit my area to, in my case, I'll just select 230 to 270 nanometers, and I click apply. And immediately, I have my complete measurement data in watt, 5,226 milliwatt, which is 5.2 watts. And we can see the efficiency of our system here is 5.75%. So the converted electric energy is converted into power at 254 nanometers at an efficiency of 5.7%. I can also go in and just click here. Let me just verify that we do have 254 nanometers. I'll just go here and say show spectra peaks. And indeed we see here that it says 254 for the main peak from our spectrum. And another thing I think is also quite interesting is actually to shift between photometric and power measurement. And we can actually see the beam shape is changing quite a bit. And that's because the reflectors, everything inside the lamp is reflecting differently at visual light waves than it does at UV light waves. So it is really important to do these kind of measurements correctly, because you might end up having blind spots here and there where actually the lamp is not giving the amount of UV light that you thought. So don't just make your UV measurement with a standard visual photometer, because it's not going to give you the correct data. And now we want to export our measurement into a PDF, and I'm going to use the UV report template. And there's a numerous round of templates you can even design. You can actually add your own logo. You can change photometry. You can add your own Excel calculations for specific projects. But we can see here we are actually getting, our peak intensity is 2 watts per square meter. So we can actually calculate exactly how many joules we're given if we multiply the amount of time. So for example, let's say your lamp is supposed to be illuminating for 30 seconds. We can say 30 times 2, so that would be 60 joules your lamp would give at a 30-second intervals. And we can, or you can also multiply it with the complete output, which is 5.2 watts here, and we can as well get the complete radiated in all directions. So we can calculate the amount of joules hitting any kind of surface in any direction, or we can actually calculate the complete amount of joules given by the lamp in all directions. And the new LabSensor Model 2 is calibrated, traceable to NIST, both in the UV region with our traceable deuterium lamp and in the visual region with our traceable tungsten lamp. So you're also going to get delivered fully pre-calibrated, ready to use out-of-the-box sensor. The sensor furthermore is also stray light calibrated for multiple series of wavelength. So that means the stray light reduction in this sensor is incredible. That means we can have a fairly small sensor that performs in the same way as much larger spectrometer does, making the system compact and easy to work with. The system is also delivered with our UV and visible traceable standard, our DT300 calibration lamp. So you can always check that your calibration is up to date and intact. So if you're thinking about getting a light measurement system, the lab spine with the UV sensor is great because you can, first of all, you can measure visual lamps, you can measure all your visual photometric data, and at the same time, you're ready for any UV challenges you might get. We have very short delivery times of the lab spine with the Model 2 sensor, down to 2 weeks, which is very quick. And we're able to ship the system anywhere in the world within 2 days. So if you want to know more about the system, please don't hesitate to contact us. Write us an email on info@visosystems.com or call us. And we can even do like an online demo where we're going to measure a lamp with you and we can go through any aspects of how the system works. Or if you have a lot of technical questions, we would love to go into detail with you. So please contact us, and thank you for watching this video.